Hi guys, we're going to look at introduction to derivatives today, hopefully to get you prepared for calculus in the future. We're going to start with limits. Definition of a limit that approaches the output for the given input value. Now, if you're struggling with that definition, replace output with y and input with x. So a value that approaches y for the given x value. Let's look at some of these graphically. Right here we have a continuous function. This is called a two-sided limit. It approaches x from the left the same value that it approaches x from the right. So right here we're looking at g of x as x approaches 2. Okay, notice if you come down the graph from the left, x approaches 2 at the value 4. If you come up the graph from the right, x approaches 2 at the value 4 as well. Here we're looking at a non-continuous function. This is called a jump discontinuity. Happens when you have a piecewise function. Okay, as x approaches 3 from the left, you actually get the output value 2. Now look, as x approaches 3 from the right, you have to come down from that top function, the top part of the function, and x approaches 3. So you get 2 values, but that's okay. This happens when you have a jump discontinuity. Now let's look at how to evaluate limits graphically. Here it's just the plug and chug method. The input is 3, the output is 12. Very simple. Definition of a derivative. So calculus is the study of change, and the derivative is just a tool for finding the change in a function. Think slope. Slope is the amount of change between 2 points on a graph. There is the definition. Mathematically speaking, we're going to look at an example of that. Okay, there's a lot of algebra in this. We have the function f of x equals x squared. A lot of algebra stuff you've learned, factoring, canceling, combining like terms. Eventually you're going to get it down. You're going to just plug and chug, plug in 0 for that h down at the bottom. You get the derivative is equal to 2x. You don't always have to do it that way. That's the good news. Practice a couple of those, and then we're going to learn these shortcut rules. The first one is the power rule. That's the one we're going to look at today. D over dx is just notation for a derivative. So we're looking at the derivative of x to the end. You bring the power out in front, and you subtract the power by 1. Here's an example. X squared. You bring the 2 out in front, you subtract 2 by 1, you end up getting the derivative is equal to 2x. Applications, we're going to look at finding the slope of a given point at a given point, finding the equation of the tangent line, related rates, and inflection points. We're just looking at those top 2 today. You'll look at more in the future. Tangent line problems. Okay, so this is where we're going to look at those 2 applications. You're given a function, you're given a point, x equals 2. You need to plug in that point to find your y value. That's into the original function. Then you take the derivative, you plug in that point into the derivative, and you get the slope of the function, slope of the tangent line. Then you use point slope form to find. We'll look at an example. Okay, we have that same function, f of x equals 2x squared minus 5x plus 3. We're given the point x equals 2. Look in the top right corner. We plugged in 2 into our original function. We got back 1. That means our point is 2, 1. Okay, next we take the derivative using the power rule. Same thing we just went over. F prime of x, that's just a way of notating the derivative. So it equals 4x minus 5. Okay. Then you're going to plug in that x equals 2, that value 2 into that derivative function. And you get back the value 3. That is your slope. It's equal to m in your point slope formula. There we have the point slope formula. We use the 0.21, plug it in. You get y minus 1 equals 3 times x minus 2. From there, you just can algebraically work it into slope-intercept form. And it makes it easier to look at, easier to apply. And that's it. Hopefully this helped out.